Okay, now we want to fit some more data, but just before we do that, I do want to show you, I forgot to show you at the end of the other video, um, that another way to go about this instead of just the haphazard moving A and B and so forth is, again, for instance, we talked about that amplitude and I could figure that all out. Well, here I approached it kind of that way, and there's some technical stuff here, but I found the maximum and the minimum of this. I can do that in Desmos. You can ask for the maximum, and I just said, see, this says y1, so I just asked for the maximum and the minimum, and so I asked for that height minus this height, and I divided it by 2 to find that middle, and I got 0.288, and I think that's about what we had in the last video. I found the period by finding where the max here and the min occurred, and I subtracted them and then multiplied that by 2 to get the period, and did a quick calculation for sine functions. If I can figure out b by taking 2 pi over that period, and that was 0.0172, and I think we used 0.018 or something like that in the video. I do remember C was 82 in our video. Here, actually, it's you get 80 if you look for exactly halfway between the max and the min. You get here, exactly halfway. And then what I did was I just found the number over here, and so I used 80 as opposed to trying to move it by that number. We had 82, and then we had moved it up by somewhere around 0.5, and that's the number we have here. So just by our trial and error with the sliders, we got about the same answer, but from the standpoint of sort of the extremes of the data and the middle of the data and those sorts of things, these are the best numbers, but again, not much different than what we found in the other video. So okay, enough of that. Let's go on. I have some tree data this time, so if I come here and I go to these trees, I've got the girth, which is around the circumference, and the height, and so the circumference should be related to the diameter, and we'll see that if I oops, not height, that's wrong, that should be volume. If we highlight that, I hope to see a relationship that would make sense here. And again, I have to paste by doing Control V. I put those in, it plots the data, and now move this kind of over here. We can scroll down to here. Now, as you look at this data, it looks very much like a straight line to some extent, but when you look at it a little longer, you realize it does seem to curve here. I think it looks a bit like a parabola. Okay, and so a parabola is y equal x squared, and so we'll do that same sort of thing. I'm going to start with f of x is equal to x squared. So that's the basic shape I want to work with, and then my g of x is equal to a f of x, f of b times x minus c. Okay, like that, and then plus D. And I will add all those as sliders and move things up where I can see those sliders. And it's off a little bit because of the D being 1 and the C being 1. If we make those 0, and I can just type that in to make it 0, and D being 0, then we're right at where we had been starting. Now, so as we look at this, there's sort of some aspects of this. We don't need to worry about both A and B. We can choose either A or B, but we don't really have to worry about both. And the reason for this is that the A is on the outside, so I get that would be like A times the quantity x squared. The B is on the inside of the F here, so it would be bx quantity squared. Well, except just square it out and you get b squared x squared, so A could just be the square root of B, or sorry, A could just be b squared. And so we don't really need both of these, so I'm not going to mess with B at all. Okay, it's just the property of this particular function. With sine, all three of those numbers are doing things that the other number can't, but in this case the A and B effectively just end up doing the same thing. It's just one is on the inside of the function, and so it's really acting as b squared, and on the outside it is just A. So I'm not going to mess with B. Okay, as I look at this, though, definitely this is not short enough, or another way to look at it is it's not wide enough. But I'm just messing with A, so I'm going to say it's not short enough, because you see, if I make it shorter, and well, this is again where I need to maybe do a 0 and a 1 here. Okay, as I make the A smaller, it makes it shorter, but you see it's also making it wider. So that's what we think of when we think of B, as making it either wider or skinnier. But in this case, for a parabola, if I make it shorter, it also makes it wider. If I make it taller, it makes it thinner. And so I can bring this down and sort of look at it as maybe somewhere in there, somewhere around about a 1/4, right? It's looking similar to that. Now it definitely needs to be moved to the right some, but not a lot. And again, so I'm just going to make that a 0, and well, the vertex is no farther over than here at like 8 or 9, and so I'm not going to go any bigger than 8. And I can start moving that to the right, and that's looking pretty good. I kind of like that. Now I could move it up with D. Now, and again, D, I'm sure I don't want it negative, so I'll start at 0, and I'm pretty sure, what is that, about 10 there. I don't want it any bigger than 10. And I can move it up, and I can kind of play with these things. There it's at 2.5, and the thing, so there, I've got it clear up here at what, 6.1, right? Well, if I do, it looks like this has to go over further, and I'm going to put that at 3.1. Now, part of the reason I'm doing this is I've done some things before. I look at this, but I think it looks either just too tall in general, in which case I'd need to make D a little smaller, or maybe it's just not wide enough, and so, I can make it a little wider by bringing that down. I get down here to, 2.22 or something like that. And kind of what I'm looking for is for about half the data to be above and about half the data to be below, and similar across the whole thing. Like this last one, there's no way I could also have one below way out here because the data just aren't out there. And, but here, it looks reasonably even, right? It looks like there's about as much data above as below, and that's the kind of thing I'm looking at. Now, in this end it's a little above, this end it's a little below, and yeah, that might be okay. If I don't like it, I can bring it back down a little bit so that that's about right on, but now that seems a little too high, but I can adjust that simply by bringing that back in. And there, what I've kind of done is, if I can get it to stay close enough, 0.23, 0.24, somewhere in there. But here, I've gotten it to touch the ends a little better than it had been. And it still seems to be going through the data. And, so I've messed with A, C, and D and gotten that. So, the quadratic, though, a little bit tougher to do by eyeballing, just because trying to figure out where to put that vertex if you only have sort of one side of the parabola, and I can get rid of that one so we aren't looking at that one anymore. When I only have one side of the parabola, I know the vertex isn't over here, but well, is that the vertex, or is the vertex more over this way somewhere? So what happens if I try to put the vertex right about here? That looks like I need to come over to about 8.5 or so. So I come over to 8. Let me make that be able to go to 9, and then actually, have it go to maybe like 8.5, and then it needs to go up here to about 10. So I do that. So you see I've got the vertex right there. Now I need to make this skinnier, so I pull it in, but notice that this doesn't look as good. So if I thought that was the vertex right there and I try to fit it that way, most of my data is up above the curve, and by the time I get it to where it looks like about half, well, yeah, about half the data maybe is above the curve, but now the problem is the half that's above is all to this side, the half that's below is all to that side. So that's not good. That doesn't look near as good as what I had when I had that moved more over this way. Where was I? I think I was around 3.1 or something like that, and then this was down here at like 4 something. Okay, so I was somewhere in there, and you see that's looking better because I'm on both sides of the line kind of the whole way. Okay, so that's some of the idea in trying to fit this. But again, I can use those 4 pieces to transform my curve, to shift it around, making it skinnier, making it taller, shifting it up, shifting it right or left, or shifting it down, and I can do all that. But of course, in some cases, depending on what the arithmetic is that's going on, it turned out we really only had to mess with A. We could have been messing with A and B, but they would have in the end been doing the same thing. So it really wouldn't have helped to do both. And let's see. So there I've fit that one. That's a quadratic in this case, or I started with some sort of polynomial. I want to do x squared in that case. You could also consider this a power function because I don't have stuff added to it, so it's not to start with anyway. So it happens to be an integer power. That's something I didn't check was, oh, well, would I like to use a different power? And, maybe that would have been an idea to do when I put the vertex right here, is to use a different power other than 2. But that is changing from this idea of the ABCD transformation to a different sort of transformation. So we're kind of deciding, well, we think, maybe it's a parabola, so we use x squared, and we decide to stick with that and then change our function this way. But certainly, again, more sophisticated software and work would allow us to not only change the A, B, C, and D, but also maybe change that power if we wanted to. But again, this is the idea of, is the model there to show the structure, or is the model there to match the data exactly? Well, definitely, I'm never going to match the data exactly, and I didn't do too badly. But the more important thing to me in this model is I am using x squared. Well, remember, the x is the girth. Okay, it's going around the tree. So my mouse is going around as to go around the tree. Well, that's the circumference. But you see, circumference is just 2 pi r. Okay, so when you have 2 pi r, it's just a constant times the radius. Well, now when we think of volume of a tree, well, you could, the trunk and so forth, think of it like a cylinder, especially trees in the woods. If you've ever gone to the woods, actually many of the trees are all the same height. They just vary by their diameter or their radius. Or circumference, any of those is a fine measure. But if I think of it as the radius, pi r squared gives me the cross-sectional area, and then if they're all basically the same height, then it's just that same height, whatever that is, times pi times r squared. Oh, right there, x squared. So we're not actually using the radius here, but it all really comes down to a relationship. The circumference is basically the radius. And you say, wow, that's weird. But it is, because it's 2 pi r, right? It's just a constant times the radius. So if I need to get the volume by taking the radius squared, well, who cares if I put a constant out in front to begin with? That's what A is doing, right? Notice, A is not pi. It's not pi r squared. And then the height, whatever the height of these things is, right? It's a number less than 1. Well, why? Well, because in that what we're using for x probably took into account the height and pi and so forth in order to get this kind of relationship of the square relationship with the volume. So that seems reasonable to me, that if I have the girth, that I probably, in a forest anyway, I probably ought to square the girth to get an idea of what these data look like. Okay, so there I fit a quadratic. We'll call that one good.